Hi everybody, I'm going to talk about a few things that have come up in the first lab and some stuff that you should have a look at for the upcoming ones. But first of all, you're all doing really well. If you can keep it up like this, it will be pretty awesome. One interesting bit here first, remember rivets, they are permanent and this is not how you want to do your swiveling points. But anyways, this gets me to the first point that I wanted to talk about, and that is some of you have been asking me where to put the servo, where to fix the servo. And what you need to do is you need to consider that the servo placement will result in different ranges of motion for your arm. If you move it all the way to the left, it will result in a small angle, and the further you go to the right, the more angle you will get out of it. But the thing here is you need to consider what you're actually doing. What are you trying to do here? And what you're trying to do is you have your little cork here, your satellite, and you're trying to move it into a target area. It's 4 cardboard boxes, your orbits we call them. Little satellites trying to go to orbit. So you kind of know the distance. It's about 2.1 meters. It might be a little bit more, a little bit less. We have reserved the right to change that. You know the boxes are 55 centimeters square. That gives it 1.1 meters there, although that too might change. We might make it a little bit wider. So what that results in is there is 2 different angles here that you need to look at. They are the nearby boxes. They have a wider angle that you need to cover in order to reach the boxes, and the farther away boxes, you get a little bit of a narrower angle. And your rig has to be able to do that, because you're not allowed to touch it during launch, right? And your servo can only move 180 degrees, and you want to use every single one of these 180 degrees to have control over your useful range. So try to not just use a small fraction of the 180 degrees to move your arm, but try to make the entire 180 degrees be equal to your useful range. That's why at first you shouldn't attach the servo permanently, but you should move it around and try a little bit. And more importantly, you should draw some sketches and do some geometry and figure out what the correct position for the servo is. And that's also stuff that can go onto your poster. But now it gets interesting, because for the next step in your challenge here, you don't just have to look at the vertical axis. You also need to look at the tilting of your unit, because to reach those further away boxes, those far away orbits, you need to launch higher. This is now the part that is design-wise up to you guys. And I'll keep this little Wikipedia animation on the screen for a few more seconds, because it's actually interesting. It shows you that adjusting the launch angle is one option, but it's not your only option. If you look at this graphic, the angle for all 3 instances is the same, and yet they go different distances. So think about, what did these guys adjust, and if that is an option for you. You will have noticed that I'm already in the middle of talking design of your system here. And we did give you these templates to build the first part of your rig. Now for the rest of your rig, while we can give you the templates for more parts, you should actually start designing those parts yourself as far as you can. You can work with the ones we give you, can add on stuff and make them better, or you can come up with completely new designs. And before I let you go, I'll show you one more little thing that we have for all of you to try. It's these little scales here. You can use them to measure the force you get from the little rubber bands. You will need to know that to proceed with your design.